So some important things first, that is, if you know 24th April, right, is the last teaching day for you, right? That is hardly 10 days, or hardly around 5 to 6 classes for every subject. After 5 classes, that's it. Within this, you have to do your practical exams also, chemistry practical exams. Alright. So 24th, everyone pay attention, and we need to complete syllabus of all subjects and get ready for your exams, okay? And this Wednesday and this Thursday, everyone must submit your practical files with all 10 experiments, and I will share the dates with you. 8 experiments is sufficient, but I will give you 10 days, right? 10 dates. Got it? Yes. So coming back to the unit 3. Unit 3 has very simple topics. Ellison phenomenon, you already seen. What type of antibodies we will detect in Ellison phenomenon? You look at cell, what antibodies are detected? Anti-nuclear antibodies are detected, right? What is this lupus cell means? What is LE cell? What is LE cell? Lupus erythematosus cell. It is a cell engulfing cell actually. The neutrophil was engulfed by other neutrophil. Right? So that is LE cell which is seen among autoimmune disorders, especially in LE cell disorders, right? LE cell disease. Okay. Still there is noise. Bhavna, you already got S marks, Bhavna, even in chemistry too. Okay. The next one is karyotyping, right? So in this topic, in karyotyping, I have given 7 written questions, written work questions, and one number is maybe 2 to 3 questions might come in exam. Okay, I given it 10 marks, 5 marks, and 2 marks, and I don't know which one will come. So definitely there is a high probability of coming unit 3 questions in the paper because already 1 and 2 completed. You already know that things are going on. Anyway. So what is the meaning of karyotyping? Counting of the normal set of chromosomes in a cell is called as karyotyping. In karyotyping, we are counting in terms of pairs. How many pairs of chromosomes we have? 23 chromosomes or 23 pairs of chromosomes we have. So pair 1, pair 2 up to 23. So 23 will be your X and Y, right? So that's it. So and we know that chromosomes, before chromosomes, you need to know cell division, P map. So prophase, metaphase, anaphase, and telophase. In metaphase, the visibility of chromosomes is very high, right? The banding of chromosomes, if you see the chromosome structure, there is a centromere, a short arm, and a long arm. P arm, Q arm, centromere, right? Centromere. And they will have some banding patterns, right? So this banding pattern, usually we will arrest the cell division in the metaphase where the chromosomes will be at the center of the cell, like this, right? Chromosomes will be at the center of cell. We are arresting here by using a chemical. What chemical we are using to arrest in the metaphase? We are using a chemical called colchicine. Colchicine. So colchicine is a chemical that will arrest the cell division, especially in the metaphase. And why we are arresting for a better visibility, right? Yeah. Then what are the steps in karyotyping? First we will collect the sample. After sample collection, what we did?
Culture.
Culturing. Very good. Culturing will end up. How will we increase after culturing?
Cold chain shipment.
Arresting in metaphase. Metaphase arrest by colchicine. Then
Harvesting.
How we are harvesting? By breaking the cell wall. By hypotonic swelling of cells. After harvesting, what we did?
Fixation.
Fixation of chromosomes, so they won't be preserved. Next.
Staining.
Very good. Staining. Then
Analyzing.
You will come. So what things we are analyzing after karyotyping? we are counting the chromosomes, and also what we are doing, we are checking the length, centromere positions, banding pattern, presence or difference between sex chromosomes, and the physical characteristics of the chromosomes will be detected. Right? We are checking the chromosomal length, its centromere positioning, and banding pattern, staining, okay, staining, banding pattern, and sex chromosomes and other characteristics. So, if you remember, in females, other thing I need to discuss will be non-disjunction. What is this non-disjunction? First of all, you need to understand the normal continuity place of chromosomes is called as euploidy. Euploidy. Okay. Normal chromosomal count is called as euploidy. That is 46 chromosomes are 43 base. Any abnormality apart from 23 or 46 will be aneuploidy. Aneuploidy. It can be two types. Either you will have one extra chromosome, this will be extra, or you will have one deletion. Reduced chromosome is called as monosomy. Monosomy. Whereas extra chromosome is called as
Trisomy.
trisomy. If you remember, if the trisomy happens to the 21st chromosome, then there is a condition called as Down syndrome. Down syndrome, where it is a trisomy of chromosome 21. And aneuploidy condition, where in Down syndrome there is a trisomy of 21. Whereas in females, if the condition is this one, X0, rather than having two chromosomes, they have only one chromosome. Such condition is called as Turner syndrome. Turner syndrome. By the way, for detection of Turner syndrome, there is a very simple test called as Buckle smear test. Buckle smear test. Usually what happens was, since there are two X chromosomes, one X chromosome will be deactivated, leading to the deactivated chromosome will have a small body, okay, small residual body in the cells of all females. All 20 females have a bar body in the, this is called as bar body, keep in mind. Bar body. Presence of bar body is very common among females, okay. So that means, just with the help of blood sample, even though the blood sample don't have male or female, still we can identify whether it's a female sample or not by detection of bar body. Got my point? Why bar body generated? Because of inactivation of one of the X chromosome. Right? Usually this is the tendency of bar body. What will be the condition or status of bar body in Turner syndrome? Absence. Very good. Since they have only one X chromosome, here even though it is a female sample, they don't have a bar body. Looks like a male sample. So you need to be cautious regarding this one. In Turner syndrome, there will be a simple blood test. We will perform a smear and we will check whether bar body is present or not. If bar bodies are absent in a known female sample, that might be a Turner syndrome. A simple smear giving a deeper insights of genetics. See? So I have given here. In this female, one X chromosome was not there. X0 condition. So there is a chance of observing bar body in this, but standard technique will be karyotype for Turner syndrome. Yeah. So abnormal condition, aneuploidy, normal condition, euploidy, trisomy, monosomy. Okay. Listen, only mammals and animals having abnormal count of chromosomes lead to disorders. But this is not the case among plants actually. Plants have tetraploidy, septaploidy, some 10 chromosomes will be there. In place of 2 chromosomes, there will be 10. So, but they can resist and they can develop into healthy plants. One good examples will be fused bananas, multiple seeds in a papaya, or absence of seeds. All these are hybrids of plants. We can even do orange and apple in the same tree, grafting. So they are possible for plants but not to humans. Don't confuse botanical genetics with human genetics. Okay? If you see in botanical genetics, they will use polyploidy, polyploidy. Polyploidy for plants, not for humans. Okay? Yeah. Anyway, I don't want to discuss other things. Maybe not number might come polyploidy, multiple types or lava. Yeah. That's not possible in reality. Okay. Anyway, next. Yeah. So coming to aneuploidy and polyploidy here, this trisomy of 21 is seen among Down syndrome, whereas absence of one chromosome seen in Turner syndrome. Right? Yeah. Then, and I have discussed about non-disjunction. This is a concept where the cell, usually 1, 2, 3, 4, 4. 4 chromosomes should migrate here, 4 chromosomes should migrate here during metaphase. But due to non-disjunction, this happened here 2 chromosomes, here we have 6 chromosomes, leading to an abnormal cell. If this becomes a sperm or this becomes a ovum, both of them, either they will be a trisomic condition or monosomic condition. That you understood. This is how trisomy and monosomy occurs, and we can't predict this phenomenon, students. Actually, unlike sickle cell anemia, where we can check the genetical tree or father-mother genes, and we can see the plausibility of inheritance of sickle cell anemia in the children. But that is not the case for chromosomal disorders. Then how to screen chromosomal disorders? How to prevent chromosomal disorders? Any idea? If we can't predict, what are the best strategies to identify these issues? So only one thing, students, upon the woman becoming pregnant, first 3 months, okay, that should not be done actually, but we can, in the first 3 months, if the baby is not a healthy fetus, we can go for abortion, right? After genetic counseling, after proper protocols, within first 3 months is a safe abortion period. So during these 3 months, we will do ultrasound. In the ultrasound, if we found any abnormalities, immediately we will do something called amniocentesis. What is the meaning of amniocentesis? Very simple. During pregnant woman in her abdomen, guided by ultrasound, we will take a sample of amniotic fluid. Okay. Yes, there are some possibilities of damaging the fetus, so we need to be cautious. That's why we are guiding with the ultrasound. We are inserting a needle. We will take amniotic fluid and we will check the cell chromosomal count. In the amniotic fluid, we will separate the cells and we will go for karyotyping. Whether karyotyping resulted in a good karyotyping or not. If there is any abnormalities, we can go for genetic counseling and we can abort. Okay. But there are many instances I have seen, I have read, that most of the parents, even after coming to know that they have abnormal fetus, especially in India, okay, across the world, they are believing that this is a God gift and we cannot destroy baby. Actually, ethically that is correct. But what is your opinion on these students? Abortion. We came to know it's a Down syndrome baby. Will you, continue the gestation? There are very good parents, even after physician guiding them to abort, the parents are not willing to kill the baby. Many times this happens, and sometimes some of those babies might end as a healthy individuals. Okay, that's possible. We are not bringing God into this equation. It's a pure genetics, pure evolution, pure random selection and nature. That's it. So why I'm telling this story? Because this is a condition where this is a Turner syndrome and that is a triple X syndrome. It's possible.